All right, here is the chapter review for Earth Science 7th grade, Unit 2, Chapter 3, which you guys learned about rocks. All right, first thing to remember is that the proportion of different minerals in a kind of rock, it can vary. So some are going to have maybe the same kind of mineral, but because it's a different amount of the mineral, it's going to be a different rock. So for instance, take gabbro, which is made up of several different types of minerals. And then there's obsidian, which, it's that black, shiny, really cool looking rock actually. And it contains no minerals at all. It's actually natural glass, which is not a mineral because it doesn't have that crystal structure. So again, remember that the proportion of different minerals in the kind of rock can vary. As we know, our Earth is built up almost entirely of rock. So Earth is almost all rock. Everything inside the Earth is metallic rock, hot molten rock. You remember magma is hot molten rock, and so rock is throughout our Earth, and then our crust is mostly is mostly rock as well. All right, here is a picture of the rock cycle. The main things to remember here is that in the rock cycle, there is no beginning, no ending, right? So parts of this cycle, if you start out, let's say, as an igneous rock, right? This can actually be changed into a metamorphic rock. It can also be changed and broken down and become parts of sedimentary rocks. So everything in here can become part of the other part. That makes it that cycle. Remember, a cycle is a never-ending thing, right? There's no beginning, no end. It goes around and around. Just remember that rocks, there is no beginning, no end. Now, the surface of the Earth, the crust, it is made up of mostly of rock and then has other things on it. But remember that sedimentary rock is the rock that is found on the Earth's surface the most. Why would that be? Well, that's because the sedimentary rock is made at the surface of our Earth. They're formed by the processes that occur at that surface. Now, igneous and metamorphic rocks, those are formed within the Earth, mostly because they're formed by heat and pressure, and so those are going to be formed within the Earth. So the majority of Earth is formed from metamorphic and igneous rock, but the most common rock at the surface is the sedimentary rock. Be really clear about that. Remember, again, at the surface, that is the sedimentary rock. It makes up about 75%, right? However, down inside the crust and everything that's down underneath that, that's going to be that igneous and metamorphic rock that is going to make up the majority of it. All right, the next section is on sedimentary rock. We're going to give that bright pink just for the heck of it. Sedimentary rock. It takes the meaning of the word coming from the word sediment, which is something that settles. So this is where you've got loose pieces of rocks and minerals, right? As well as plants, animals. I'm not going to draw that. All of that can become a part of a sedimentary rock. Sedimentary rocks develop from layers of sediment that build up on the land or the water. Remember, these are the ones that are going to be layered. Think back to the lab that we did where we had the different kinds of rocks. We had the pebbles in the bottom of the cup, right, with the plaster of Paris. And then we had the sand in here, and then we layered more pebbles on top. And that created a sedimentary rock because of those layers. Within these layers, you're going to get a different type of rock getting pressed together, right? So the top layer is going to press down on the next layer, and the next layer up is going to press down on that layer, and that's where you get that overlying layers that are applied pressure. They're going to press down into the sediments underneath, and that's what's going to cause those rocks to be cemented together. That cement is the minerals, or can be, minerals that have crystallized between the layers, or it could be, such as in silt and clay, they can just be formed by that pressure, but other times it is going to be the minerals that have crystallized, and those are going to act as that cement again that's going to hold them together. Over a long time, it can transform those loose sediments into those sedimentary rocks. Okay, there's also fossils. Now, fossils are also part of sedimentary rocks, but these are the rocks that are made from the remains of shells or plants. Coal is, not my son, just coal. Coal is made up of the remains of dead plants. Again, let's draw our plant here right, as well as dead wood, bark, leaves, stems, roots. All of these kinds of things actually make up coal. Coal isn't made from the minerals and stuff. It's made from those dead plants and roots and bark and so forth. So again, as coal, as plants died, the remains fell upon the remains of earlier plants. So they're, again, creating those layers we just talked about. And then layers of other sediments buried the layers of plant remains. And then the weight of the sediments above, they press this all together. So they press it, and that causes it to create coal, that pressure. Limestone is another form of sedimentary rock, but this one is made of carbonate minerals, including things like calcite. Right? The shells and skeletons of ocean organisms typically are going to form these minerals, and when those organisms die, the shells and skeletons settle onto the ocean floor, again as layers. Remember, we're talking about layers because this is sedimentary rocks, and over time they're going to be buried beneath other things, other sediment, which is going to press them together, and you're going to get those sedimentary rocks again forming. Now these, again, typically limestone is under the ocean because it's these creatures, these animals that are made of carbonates that are going to cause those to occur. Sedimentary rocks can also be formed when dissolved minerals reform from water. So you're going to have some substances that are going to dissolve in water, and then they're going to reform when that water evaporates. I mean, think about like when you have a glass of salt water or sugar water, right? When the water evaporates, you're going to be left behind with the stuff that's there. Well, the same thing happens with sedimentary rocks that are made up of minerals that crystallize as the water dried up. So the water, it dries up the particles, and they leave behind the sedimentary rocks. So remember, there are 3 different ways that rocks, that sedimentary rocks form, right? So there's that they build up in layers, and get pressed together. Okay. They can also build from shells and plant remains. And then they can also form from dissolved minerals that reform in water. So pay close attention to this. You need to know this. And the last section regarding sedimentary rocks is to know what they can tell us about our world and about what has happened in our past, right? So because sedimentary rocks are laid down, again, in those layers that we talked about, because they're laid down in those layers, they actually can gather a lot of information in them. Scientists can study them. They can tell what conditions were like in the past, when weather changes happened, when floods happened, when great drying times happened, when ice ages happened. So they can tell us all that, along with the fossils that happen within those layers. All of that can tell us much about what has happened over time. Okay, for instance, if we're looking at those mud cracks, say we've got these mud cracks that are occurring in these sedimentary rocks, we can see within these mud cracks where a flood would have happened or where a drying spell would have happened. It's going to show us, like if a flood is happening, we're going to see that there's large particles of sediment that are at the bottom and lighter particles, smaller particles are at the top. And so that's going to show us that a flood happened at that point. Scientists can use this information to learn a lot about what has happened in the area. The next type of rock we're going to talk about is igneous rocks. Igneous. Okay, so igneous comes from the word for fire, so which makes sense because ignite, think of ignite, igneous, fire, all of that comes together. And the way that makes a lot of sense is that heat is one of the big processes that is used in igneous rocks. In order to form igneous rocks, you have to have that heat. They are formed from molten rock. Now, the type of igneous rock is going to vary. The origin of it is going to depend on where it forms. So they're classified as intrusive igneous rocks and extrusive rocks. If we look at this diagram, we have our extrusive igneous rocks up here, along with these two types right here. And these form extrusive igneous rocks because they cool on the Earth's surface. So it's extrusive, meaning it's outside. Now, intrusive, again, that word intrusive, these are the ones that form inside our Earth. And they cool within the Earth as it forms intrusive igneous rocks. Again, these are examples, granite and gabbro. Now, the texture of igneous rocks, remember texture, that will be on the test. The texture of igneous rocks, meaning the size of the mineral crystals, this is going to depend on how cool the magma or lava, depending on if it is intrusive or extrusive. Remember, magma is inside the earth, lava is out. So how fast those cooled. So that's going to change the size of the minerals, which is going to change the texture of your rocks. So if we look at the intrusive igneous rocks that are formed from magma, so again, that's going to stay down inside. So that's going to allow large crystals to form because the interior of the earth, as you know, is extremely hot. There's high temperatures, which allows the magma to cool slowly. And that slow cooling allows time for those large crystals to form. Take a look at this picture. So again, let's talk about these intrusives, right? The intrusives are these ones down here because they're happening down here inside. So because they're inside, it's much hotter. You're going to have higher temperatures, which is going to allow the crystals to grow at a long time. It's slow cooling, so it allows them to grow for a long time. Now these extrusive ones, these are going to reach the Earth's surface. They're going to not have that high temperature, which means their crystals are going to cool pretty fast, which means you're going to get small crystals. If you look at the differences between these two types of rocks, right? If we look at diorite, you can see that it's got much larger crystals. You see the definition between the different colors within this rock. However, basalt, the crystals are going to be much smaller, as you can tell. It's very fine-grained, so it doesn't have those large crystals. There are even some rocks that have both of these, and that's because those have come out as the magma has erupted onto the surface, such as from a volcano. So you're going to get some rocks that have a little bit of intrusive and a little bit of extrusive. If you think back to when we learned about volcanoes, this next part should make some sense to you, right? So most igneous rocks, remember, they're from inside the earth, and they're mostly down in that hot magma chamber and so forth. So they're mostly made of silicate materials. Remember, silicate was that combination of silicon and oxygen. And if you, again, remember back to volcanoes, when we talked about volcanoes, you're going to get different flow with different amounts of silica. Well, the same thing happens with igneous rocks, right? So if you have igneous rocks that have a high level of silica, so these are ones like granite, they're typically going to be light in color. If they have a low amount of silica, they're going to be dark. And possibilities of these are like the couple rocks we just talked about, gabbro and basalt. They're a dark color because they have a low amount of silica compared to a light colored rock that has a high amount of silica. The last part about igneous rocks is to think about what happens when weathering and erosion and so forth happens at the surface, right? If we have something like a volcano that's slowly cooled into rock, and then over time wind and water wear away the weaker rock that is surrounding that interior rock, then what you're going to get is you're going to get a giant intrusive igneous rock, but it's going to be up on land. So you're going to get a giant mountain, but it's going to be intrusive igneous rock that has made it because it's a pretty strong rock, and all the weaker rock that was covering around it has been blown away. Our last section is on metamorphic rock. Metamorphic, right? This is a change. These rocks are changed. Most of them come from originally being sedimentary igneous rock. Now that sedimentary igneous rock is now the parent rock, and we result in a metamorphic rock because it has changed, it is metamorphosized. And it can actually be a parent rock for another kind of metamorphic rock. Remember that whole rock cycle. During metamorphism, so these rocks are going to get lots of changes, right? They can be under a lot of pressure, which is going to flatten all the minerals into one direction. That's going to change the rock's minerals. They're going to remain solid, but they're going to change. But rocks in the metamorphic do not melt, because if they melt, then, well, now you've got an igneous rock, right? If it goes too hot, it's going to become igneous, not metamorphic. It's that heat and pressure that's going to break those bonds. So those atoms that are joined together in the minerals, the heat and pressure are going to break those. And as they break, then the atoms are going to join together in a different way, in a form called recrystallization, which is going to result in minerals that have crystals that grow larger as the atoms join, or they're going to combine in a different way, and new minerals are formed in place of those older ones. Take a look at this picture here, right? We have pressure and temperature. Remember, the further you go down into Earth, the higher the pressure, the higher the temperature. So you're going to get different types of rock at each of the different levels. So let's say this level 1 that's closest to the Earth, you're going to get shell, right, which is a sedimentary rock. So it's buried deeper, but it blocks of the crust. It pushes them together. Now it changes to slate. Slate changes to phyllite. Phyllite changes to schist, and schist changes to gneiss. So it's it's the same rock, it just changes because the amount of heat and pressure it's under. Changes in metamorphism or metamorphic rock can occur over large and small areas, right? So the type of change is going to depend on the type of parent rock and that temperature and pressure. When both high temperature and high pressure are present, metamorphic changes can occur over the large areas. So when you have large area change, this is when you're going to get high temperature, high pressure. Now, if you have only high temperature or only high pressure, then you're going to get those small areas of change, like shown here in the bottom pictures. For an example, so if you have an area where you've got large blocks of rocks that are pressing together and pushing up mountain ranges, let's see if you can remember what that's called. Give you a moment, right? Right, convergent areas, right? So in that area, if you've got those rocks pressing together, pushing up mountains, you're going to get that metamorphosis that's going to happen, and you're going to get a large area of change. Small change can happen in areas where you have maybe magma coming up or lava coming from a volcano, which is going to cause that recrystallization to happen. There you're going to have one or the other, typically temperature, but you're going to have a small area of change because it's just the temperature that's causing the change, not temperature and pressure. All right, should be one last item, and this last item has to do with metamorphic rock again, and this is regarding foliation. Remember that word right there. So this is going to happen. Foliation is the arrangement of the minerals where they're going to change. They're going to become flat or wavy parallel bands, which is characteristic of most metamorphic rocks. Foliation develops when rocks are under pressure. So it consists almost one type of mineral. It will not show foliation, but if it has multiple types of minerals, you're going to see this foliation. You're going to get those layering again because you're going to get those bands of minerals. These are going to happen when minerals flatten out or line up into bands. Here is a couple of examples of that, right? Phyllite here. Is a foliated metamorphic rock. Contains several types of minerals, and if you look here at the microscopic image, you can see that they're all lined up into these bands, and so you can tell that it is a foliated rock. Now down here, marble is not, right? It consists of almost entirely one type of mineral, and so you're going to get crystals that are going to form in bits. They're not lined up, they're not in bands, so this is a non-foliated metamorphic. This is a foliated metamorphic rock. And that's the end. So study hard.